In this concept, we're going to learn how to graph quadratic inequalities. Now, graphing quadratic inequalities uses the same techniques as graphing linear inequalities, which we did discuss in a prior concept. Let's look at the steps. First, decide if the parabola of the quadratic inequality should be solid or dashed. Okay, so it would be solid if you had a less than or equal or greater than or equal sign, and it would be dashed if you had a less than or greater than sign. So, okay, meaning no equal with the inequality sign. And then choose a point, x1, y1, just any random point inside the parabola or outside the parabola to see if it is a solution or not. Okay, if the point is a solution, and the point happens to be, if you chose a point from inside the parabola, and it is a solution, meaning it does give you a true inequality expression, okay, shade the region inside the parabola. If you choose a point inside and it gives you a false inequality result, then you shade the other region, which is the outside region. Okay, and conversely, if you chose a point outside the parabola, if you chose a point outside the parabola and it works, it gives you, you plug it into the inequality expression, it gives you a true mathematical inequality, then you shade the region that's outside the inequality, the parabola. If you choose the point outside the parabola and it gives you a false inequality expression, then shade the region inside the parabola. Okay, so basically you just test any point, right, whether inside or outside, and then depending on whether you get a true or false inequality expression result, you shade the appropriate region. Let's look at an example of how this would play out. So graph y is less than x squared minus 3x minus 10. So start by graphing the equation y equals x squared minus 3x minus 10. Why did we convert this to an equation? Well, because the equation essentially gives us the limit or the boundary of both regions, right? The non-solution region and the solution region. So first we graph the equation, right? So x squared minus 3x minus 10 gives us this parabola, right? You can convince yourself that this is the parabola for this equation, right? You know, complete the square or use whatever method necessary to identify this parabola and be able to graph it. Once you've done that, the first step is to recognize that the parabola should be dashed, okay, because the inequality symbol is less than, okay, it's not less than or equal. Now, let's test the random point 6 and minus 12. Okay, so 6 and minus 12, which is the point right here, which happens to be outside the parabola. So when we say test the point, we mean take both coordinates of the point, plug them into the equation. So plug the 6 for the x and plug the minus 12 for the y, right? So you have minus 12 is less than 6 squared minus 3 times 6 minus 10. Test this inequality. See if it is true. Okay? See if minus 12 is indeed less than this whole expression on the right. Now, simplifying the expression on the right, we'll get minus 12 less than 8, question mark, because we're still testing the inequality. Is this a true or false mathematical statement? It is true. Minus 12 is less than 8. Okay, minus 12 is less than positive 8. In which case, since the point outside the parabola did work, did give us a true mathematical result from the inequality, then the region outside the parabola is our solution to this quadratic inequality. So shade the region outside the parabola. Okay, so the shaded region outside the parabola is the solution. Okay, this is it. It's very straightforward. You just have to follow the steps that we discussed. Let's look at some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so we want to graph the following quadratic inequalities. So y is greater than or equal to x plus 1. So let's first graph y equals x squared plus 1, right? So this is our coordinate plane. It doesn't look the greatest. Let's try it again, right? So this is y, okay? X squared plus 1. Well, how do we graph x squared plus 1? Well, y equals x squared, would look like this, right? So plus 1 means that we're just going to lift it up, we'll lift the vertex up and the whole curve up by 1. So this is going to be my y. Oops. Yeah, let me try this again. This is going to be my y equals x squared plus 1. Okay. So this is my graph. Y equals x squared plus 1. So since I have a greater than or equal to sign, it's going to be a solid graph, okay? Not a dashed graph. Now let's pick any point to test. Here's a trick, okay? If you test the origin will make it very simple, because the origin will just, do away with x and y, and it'll be very easy to test whatever's remaining. So the origin is the point 0 and 0. Okay? It is by far the quickest way to test an inequality in this case. Okay? So try to use the origin more often than not. In this case, the origin is outside of the curve. Okay? So if the origin does fulfill this inequality, or if the point at the origin, the coordinates of the point at the origin, fulfill this inequality, then the outer region will be the solution and will shade the outer region. If the origin does not fulfill this inequality, if we do not get a true mathematical result, okay, for this inequality, if we plug in the coordinates of the origin, then the outside of the curve is not the solution. The inside of the curve is the solution and will shade the inside region. Okay, so let's try it out. So we have y is greater than x squared plus 1, right? If we plug in 0 for x, 0 squared plus 1, and then y, we plug in 0 for y. So we have 0 is greater than or equal to 0 squared, which is just 0, plus 1, which is just 1. So is 0, so, I'm going to put a question mark over it to say that I am still testing it. Okay? Is 0 greater than or equal to 1? Well, no, it's not. It's not greater than 1, and it's not equal to 1. Okay? So this is a false statement. If this is a false statement, that means the point that I chose is not part of the solution. And therefore, the whole region around the point that I chose is not part of the solution. Okay? These are x's, by the way. This is not shading. I'm just saying to ignore this region. Okay? So the outside of the parabola is not part of the solution. What is part of the solution? The inside. Okay, so the solution is whatever's on the inside. So I'm just going to shade the inside of the parabola. And this is my solution. Okay, this is my solution space. Let's look at the next example. So we have y is greater than minus x squared minus 3x minus 2. So again, just follow the steps that we discussed. So we have y equals minus x squared minus 3x minus 2. We want to graph this. So what we need to do is see how we can convert this to standard form or vertex form. Okay, this is not a perfect square, so we need to complete the square to make it a perfect square. But we start here with a negative sign, so we don't want that, right? We can't get to a perfect square if the a is negative. So what we need to do is, well, we can actually factor out a negative, a negative 1, right? So a negative, so we have minus x squared plus 3x, right? And since I need to complete the square, I'm just going to factor out the negative from just the first two terms. And then I'm going to leave the minus 2 as is. Okay? So then, x squared plus 3x. So remember, to complete the square, we have b over 2 all squared. So b is 3 in this case. So we have x squared plus 3x. So 3 over 2 all squared is 9/4, right? Minus 2 plus 9/4. Now notice what I did. Why did I do plus 9/4 here? Didn't we say that, if I'm adding the third term, then I need to subtract it to keep the equation balanced? Well, so I added 9/4 inside the parentheses, but keep in mind, the entire parentheses is subjected to this negative sign, right? So this is essentially minus 9/4, right? When I take this out of the parentheses, it's minus 9/4. So to balance the actual equation, I need to add 9/4, right? So now I've subtracted 9/4, which is inside these parentheses, and then I added the 9/4 out here to balance the equation. Okay? Again, interesting trick. The only way to get better at solving these tricks or recognizing these tricks is to just keep practicing with solving more and more problems. But this is how you do this. So, okay, so now we can complete the square, which is going to give us minus x plus 3/2. So square root of x squared is x. The square root of 9/4 is 3/2, all squared. 2 is 8/4. So minus 8/4 plus 9/4 is plus 1/4. Okay, so this is my standard form. So now I'm just going to graph this. All right. Actually, let's graph it a little bit to the left. So my A is minus 1. My H is minus 3/2. Okay. And my K is plus 1/4. Okay? So let's put the vertex. So the vertex is at minus 3/2 and 1/4. So minus 3/2 on x, minus 3/2, right? And then up 1/4 on y. This is my vertex. Okay? And then with a being equal to minus 1, why is this erasing? Okay, here it is. With a equaling minus 1, I know the graph opens down. Okay? But keep in mind, since this is just a greater than, so I need a dashed curve. Okay? So again, I need to test a point to see which region is the solution region, right? Inside the graph or outside the graph. Okay? So again, by far, the easiest point to test is just the origin, 0 and 0. So let's plug in 0 and 0. You can plug it back to the form you were given for the problem, or you can plug it into the standard form that we have, determined. Either way is fine. Actually, plugging it in here would seem to be easier because then, so this x would go away, right? So you plug in 0 for x, 0 for x, 0 for y, right? The origin, right? 0 and 0. So this goes away, this goes away, this goes away. So we'll have 0 is greater than 0, minus 0, minus 0, minus 2, right? So this is just, 0 is greater than minus 2. Test this. Is 0 greater than minus 2? Well, it is. 0 is greater than minus 2, right? So since this is a true mathematical result, then the point I chose is part of the solution region. So since the origin is outside the graph, the solution region is everything that's outside of the quadratic curve. Okay, everything out here. Okay, this is, this. Okay, very good. I hope this was clear. This is it for this concept. See you in the next video.